In this video, I'm going to help you understand how to apply the zero and negative exponent rules. So just kind of to talk about the definition of a negative exponent, it says here that a to the negative n is a reciprocal of a to the positive n. So a to the negative n really means that your term, your base, should have been in the fraction, in the denominator of a fraction all along. And this is going to work when a is not 0. So a negative exponent just means that the base is on the wrong side of the fraction line, meaning top or bottom. And so you need to flip the base in order to get it in a positive exponent format. So x to the negative fourth would be the same as 1x to the negative fourth. And the base, x, will move down to the denominator, and the exponent, 4, will turn positive. And I want to explain why it is like this. So I'm going to flip my paper over to the back, and I'm going to give you kind of a helpful tool. I'm going to start with a number, a simple number, 2, that we know pretty well. And I'm going to talk about how I know that. So just real quick, 2 to the first power is 2. 2 squared is 4. 2 again times another 2 is 8. And 2 to the fourth is 16. And I'll just do one more here. 2 to the fifth, so double this, is 32. Now this process keeps going on and on each time you up the power. And I want to show you why you have a negative power that goes to the denominator. I'll show you here. So if I take and I look at how, as I increase the power, this is going up here, we're multiplying by 2, right? Each time we go forward to the right, we multiply by 2. But if I want to go backwards, I have to undo a multiply, or the inverse of that, which means if I go this way, I would divide by 2. So multiply by 2 this way, divide by 2 going that way. So 2 divided by 2 is 1. And 1 divided by 2 is a half. And if I divide that in half, divide by 2, I get 4. Divide that in 2, I get 8. Divide that in 2, I get 16. Divide that in 2, I get 1 over 32. Oops, I wrote a 1. Here we go. So notice how these numbers show up here. 4 and 4, 8 and 8, 16 and 32. And if you take a look at your powers, look at the powers here are going up by 1. If we go backwards, my powers will go down by 1. So subtract 1, subtract 1, subtract 1, subtract 1 more, subtract 1 more, and subtract 1 more. So this is how that kind of works out. It's because when you multiply your 2's more and more, you multiply your 2's to go to the right, to get bigger. And as you're going smaller here, you know, divide by 2, 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 you divide by 2 to go back. So I hope that kind of scenario helps you understand at least why that rule is the way it is. Okay, so now let's actually do some practice problems. 5 to the negative 2 just means your base of 5 was on the wrong floor of the fraction. So kind of think about it as over 1. Bump it to the bottom and its power becomes positive. Now we can simplify that a little more. That would be 1 over 25. Again, y to the 6 just means that it should have been in the denominator of your fraction, because here it is on top. And then the 6 will be positive. That would be my most simplified version there. 3 times x to the negative 2. Well, this is 3 to the positive 1. Times x to the negative 2. Don't move your 3 to the denominator because its power is positive. So leave it upstairs, but bump your x squared to the bottom and its power will become positive. The next one, again, similar thing. 7 is given a power. It's not written there, but it's given a power of 1. And then you have y to the negative 5th. So this would be 7 over y to the 5th. Positive 5 then when you bump it down. Maybe you want to try the next couple and we'll see how you do. Hit pause. Oh, hey, welcome back. Okay. Distribute your negative 4 here to both your 6 and your x. Now, if I move both of these to the denominator so that they can have a positive power, what gets left over on the top? And what gets left over on the top isn't 0, it's 1. If it was 0, the whole fraction would go away. And we don't really have 0, we have some stuff here. So let me just fix this. 6 to the 4th power definitely need a calculator for that. 1,296. So let me simplify here. 1,296 x to the 4th. And there's our answer here. Now for the next one, notice how in this fraction, every single letter has a negative power. That just means every single letter needs to move floors. So this needs to go down, this needs to go down, and then this guy, the z, needs to go up. So z will now be upstairs with a positive 6 power. Your x to the 4th will be downstairs with a positive power, and your y, again, downstairs in the fraction with a positive power. I should say denominator, but it's the down of the fraction. Okay, the next one, again, only move a letter with a negative power. So I notice that this guy is positive. Leave that term alone. So let's flip the other stuff. I'm going to leave that c to the 5th alone. But my a to the 8th is going to come downstairs. My b to the 3rd is going to come downstairs. And then these two are going to go up. A to the positive 2, b to the positive 6. Now that I have positive powers, let's do some canceling. So this would be A, B, 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 1, 2, 3, 4, 5. I need 6 of those. And then I'm just going to write c to the 5th. There's no c's that are going to cancel here. Now 1, 2, 3, 4, 5, 6, 7, 8 A's, and then 1, 2, 3 B's. Well, 3 B's are going to cancel, and I'm left with 3 on the top. And let's see how many A's are going to cancel. Just 2, those 2. So I'm left with 1, 2, 3, 4, 5, 6 A's in the denominator. Or more simply, I just kind of look at the powers and I say, all right, if I'm just looking at my 2 A's, you know, imagine those other ones aren't there, but there are more A's in the bottom because 8 is bigger. Well, how many more does the bottom have? Well, 2 compared to 8, there are 6 more in the denominator. And then if I start comparing my B's, there are 6 B's in the top, 3 B's in the bottom. How many more B's are on the top? Well, there's 3 more B's. It's kind of like, you know, just where'd you have more? Those more stay there.